In order to start modelling, we had to find a reference image. We focused on Matt Dixon's robot drawings, and I chose Memories from 2019, which features a small gumball robot holding a gumball. The model began as a blockout, simplistic shapes that got the general shape and design of the character. I started at the head and moved down to the torso, then the arms and the legs. The first detailed part of the model that I created was the coin receptacle area of the gumball machine. It started off as a rectangle that had been flattened out and subdivided, then had been bent around the curvature of the object. This was difficult, however, as it had a lot of minute details, such as a circular hole cut out into it where the coin presumably would go, alongside a drawer. This made the topology very difficult to get right, and actually the original version was created using booleans, especially subtraction booleans. This meant that a lot of the shapes created by this process were actually n-gons and were unsuitable for the model. The secondary version, which can be seen here on the right, has a lot more preparation put into it. For example, leniency around the main hole at the top, and a lot more quadrilaterals, four-sided shapes, as the main bulk of the model, with less triangles. This meant that upon viewing the model and rendering it, it appeared more smooth and less rough and blocky as it did in the first iteration, meaning that the model looked more realistic and much more stylistic and much more pleasing. Next up were the arms and legs. These were mostly cylindrical shapes except for the forearms and the shoes. However, luckily they were able to be copied and mirrored, so I only had to model one side. The main issues with the model was with the boots. They were very jagged and very rough looking at the top, around where the ankle was. This was because a lot of editing of the mesh itself had to be done, including a lot more triangles and repositioning of parts. However, this ended up being fixed simply by setting it to being smooth shaded, which a lot of the model wasn't by default. At this point, however, a lot of the model was still in sections. The arms, legs, head, body, neck were all separate objects and had not been unified. This was easy to do, however, as you just select all and then combine within the Boolean menu. This led to the finalized version of the model. The first part of rigging the model is creating the skeleton, as can be seen here. The skeleton was created on flat planes, meaning it would line up better, and a lot of it had been duplicated and flipped in order to be mirrored across an axis. The next part was implementing inverse kinematics. Most of the model up to this point had been forward kinematics, meaning that it had to be controlled upwards from the base, so if you wanted the head to tilt forward, you had to tilt the neck, then the head. However, the arms and legs were inverse kinematics, which means they would be calculated by moving the final part of the joint. This required 4 IK handles on both hands and feet. This isn't suitable for animation, however, so control surfaces had to be created using curves. This allowed a more simplistic interface for a person to use that was more user-friendly. This required parenting objects together in order to allow the user to move bones without having to actually interact with the skeleton of the model. Other objects could also be added, such as the elbow and knee control surfaces, which allow the knee and elbow to be pointed towards a certain direction while being independently moved by the hand and foot. This allows a much more freedom within posing. Here you can see the main control surfaces are on the torso, head, neck, feet, and arms, and of course fingers. At this point, weight painting had to be conducted. This was simple as, of course, the robot is a hard body, which means it doesn't really have to bend at all in places that would require more advanced weight painting. So a lot of the weights are 1 or 0. They are not a blend, they just bend without influencing anything else. The one exception to this, however, on this model is the neck and the feet, which had to be hand weight painted in order to bend properly. In order to start texturing, UV wrapping had to be conducted first. This is the process of unfolding a mesh and allowing a texture to be placed on it on a 2D surface instead of 3D. This model had to be unwrapped twice, as the first time I personally used a lot of perspective unwrapping, which means that the object was mirrored down a plane or an axis. This means that the model can be unwrapped in a lot of a smaller space, which I deemed to be more efficient at the time. However, I was wrong, as it creates seam lines that are much more visible to the viewer. For example, on this render of the robot, you can see down the center of the head is a line where it is clear there is a seam. This is fixed, however, by unwrapping the parts again, meaning that a lot of them were now individually unwrapped, and none of them are mirrored across an axis, which means the textures look more natural and there was less visible seams, which means the model generally looked better and more appealing. The first version of texturing for the robot was done using Maya's default Lambert shaders and materials. This meant that it looked cartoony and very flat, which in some aspects worked for the model itself. However, quickly, we changed over to Arnold shaders, specifically AI Standard Surface. The materials and images and height maps and all the texturing was done within Substance Painter, a piece of software that allows procedural generation and painting of textures onto 3D models. The robot had several different versions of this, as I wanted to try and go for a more rusty and old aesthetic that made the robot seem unused and abandoned. This image was one of the first times I experimented with rust and procedural edgeware. This didn't work, however, as the rust and the metal were inversed, meaning that where rust should have been, there should have been metal, and where metal should have been, there should have been rust. However, this was very easy to fix by just inverting the mask used. This can be seen here. I believe this looks much better than the previous version, as now it looks more accurate to how things rust in real life, where the most interaction and use comes from. This focuses around the joints and around the draw mechanism, where people would be touching it in order to get the gumballs out. One issue with this version of the model, however, is the paint does not reflect the wear and tear that I wanted to produce. However, this could be fixed using more procedural generated effects within Substance Painter, including dirt, edge wear, and also alongside that hand-painted elements that make the robot look to seem that it's been repainted, especially around the shoulders and on the metallic parts. This makes it seem like the robot was attempted to be restored at some point, however was still abandoned. This image is the final render and the final version of the model. It is fully posable, rigged with control surfaces, and also fully textured. I believe the paint on this version looks a lot better, a lot more hand-painted, and a lot more dirty, fitting with the theme of the robot I wanted to create. The first part of compositing is taking the base photo. This is a photo from Portsmouth. It's behind a local restaurant next to the bins. I believe this fits the theme of what I wanted for the robot, making it look abandoned and thrown away. An issue with using my phone camera instead of a rented or loaned camera from the uni or any sort of professional photography equipment is, of course, by default, I do not know the parts and attributes towards the camera. There is two ways that I got this information. Of course, I looked up the information of the camera online, I found several documentation guides and such on the camera, for example this one. But alongside that, in the photo metadata itself, there is also information on the camera, which allowed me to input this into Maya, making the digital camera used to render the scene as close as possible to the actual camera used to take the image. This camera information allowed me to align the digital camera with the physical camera, and therefore allowed me to pose the robot and the bin that I made onto the background plate, making it easier to composite onto each other. The light source of the render was a HDRI. This is a sort of file that encompasses a scene within a 3D space, therefore allowing you to map the lighting of that scene to an object. My one was got from Polyhaven, and it is called Cambridge, assumably taken in Cambridge. For compositing, we used a software called Nuke. Nuke works based upon a node-like structure, where images can be put through filters and joined together using nodes. This is similar to how shaders and materials are made within Maya and other 3D software. After aligning the two images, creating a mask to allow for the shadow to be put down, and also colour adjusting the render, it allowed me to create a final composite of the two.